Dinosaurs ruled the Earth for over 165 million years, but we still don't know what most of them were like. We have no idea what color they were, how fast they could run, or even what their voices sounded like. But there is one important thing that scientists would really like to know about these long-extinct reptiles. How warm were they? Hi, it's me and this is Minute Earth, trying to figure out the body temperature of dinosaurs. Also called their thermonegative is surprisingly tricky, because unlike mammals and birds which come in a range of sizes and have different levels of fluffiness, most fossils are just bones, and you can't tell much about an animal's thermal biology from its skeleton. So scientists have had to get creative with what limited evidence we do have, like skin impressions preserved in rock, chemical signatures in dinosaur eggs and proteins and collagen in fossilized feathers. But none of those sources have given us a clear answer about whether dinosaurs were cold-blooded, warm-blooded, or somewhere in between. And that matters not only for understanding how dinosaurs functioned, but also for figuring out why so many of them went extinct 66 million years ago. To figure out what the theropod did, we need to start with the mystery of Miss Chan. That's the nickname of a relative of Ankylosaurus in the genus Boreapelta. The fossil of this particular dino was found in 2005 in the genus Hell Creek Formation in Montana, the same place where the type specimen of Tyrannosaurus rex was found. But while T-Rex is one of the best-known dinosaurs, Miss Chan is pretty obscure. That's partly because when she was first discovered, she wasn't in great shape. Her skull was crushed and her ribs were broken. But since then, researchers have used X-rays to reconstruct her skull and CT scans to see inside her ribs, finding that Miss Chan was about the size of a Labrador retriever and weighed around 30 kilos. She also had a thick coat of armor on her back and tail made up of small flat plates of bone called osteoderm. And unlike most other relatives of Ankylosaurus, Miss Chan had feathers. Unfortunately, though, the fossil didn't preserve any skin impressions, meaning we have no idea what those feathers looked like or how many she had. But what we do know is that Miss Chan lived during the very last period of the Cretaceous, a time when the climate was warming. So, in 2020, paleontologists studying Miss Chan hypothesized that she may have been a thermoregulator, an animal that can keep its body at a constant temperature regardless of the environment, kind of like us humans. Mammals and birds aren't the only animals that can do this. There are a few reptiles that can too, like the blue-tongued skink, which lives in Australia today. And thanks to Miss Chan's unusually thick osteoderm, which may have acted like the armor plating on a Volkswagen Beetle, trapping heat inside, the researchers thought that she may have been a particularly good thermoregulator. If she was, that would make Miss Chan the first dinosaur we've found that could regulate its body temperature. But to test this idea, they needed to figure out what Miss Chan's metabolic rate was, which is how much energy she burned per day. That's because an animal's metabolism is directly related to its body temperature. Cold-blooded animals have slower metabolisms than warm-blooded animals. In order to measure Miss Chan's metabolism, the researchers gave her the same allometric equation scientists use to estimate the metabolic rates of modern animals. This equation takes into account things like mass, surface area, and the amount of energy an animal needs to move around. It turns out that Miss Chan needed a lot of energy to power her daily activities and maintain her body functions. She would have needed to eat more than 350 pounds of food every year to fuel her metabolism, which meant that Miss Chan would have needed to be a carnivore. That doesn't seem likely though, because most relatives of Ankylosaurus were herbivores. Miss Chan's mouth and teeth do want to look like they were adapted for catching and chewing through flesh. So it looks like Miss Chan wasn't a true thermoregulator after all. Instead, she was probably that's a fancy word for animals whose body temperatures are somewhere between cold-blooded and warm-blooded. Like Miss Chan, most mesotherms rely on external sources of heat to warm up, but they can also generate heat internally to maintain a stable body temperature, at least for a little while. Since Miss Chan was big, she would have absorbed heat quickly from the sun or a hot rock, and because she was covered in insulating feathers and armor, she wouldn't have lost that heat right away. So she may have been able to regulate her body temperature for a couple of hours each day, which would have been enough time to be active and search for food. Being mesothermic allowed Miss Chan and her relatives to take advantage of the food and opportunities available to them without having to worry about getting too hot or too cold. But it turns out that being mesothermic may have been one of the reasons why Miss Chan and her relatives went extinct. See, because they relied on external sources of heat, Miss Chan and her relatives needed to bask in the sun for long periods of time in order to get their body temperatures up. But it turns out that the asteroid that killed off the dinosaurs also kicked up a ton of dust into the atmosphere, and that dust blocked sunlight and caused global temperatures to plummet. So basking dinosaurs everywhere, including Miss Chan, were met with a long, cold darkness. And since they couldn't regulate their body temperature internally like mammals and birds do, they probably died pretty quickly. Okay, so that's one dinosaur down, but there are still plenty more to go. And we're just getting started on solving the mesothermic mystery. One promising lead is preserved poop. You see, like Miss Chan, most dinosaurs left behind mostly bones, which don't say much about their body temperature. But preserved poop, also called can contain clues about diet and digestion, which can shed light on an animal's metabolism. In 2022, researchers reported finding fossilized poop from a relative of Ankylosaurus in the genus Mesothermic. The fossil dates back 76 million years and comes from the genus Kuiperowitz Formation in Utah, and it contains lots of interesting stuff, including bone fragments, plant matter, and even bacteria. And by analyzing the chemistry of those remains, the researchers found that Mesothermic had a surprisingly high metabolic rate, higher than that of modern cold-blooded animals and even some warm-blooded animals like horses and dogs. And that suggests that, like Ms. Chan, Mesothermic was probably made. In fact, based on the chemistry of their poop, Mesothermic and Ms. Chan were probably both endothermic, meaning they could generate their own heat internally. But while Ms. Chan was probably only warm for a few hours each day, Mesothermic could stay warm for months at a time. Of course, more research is needed to confirm that. But if it pans out, it would mean that Ms. Chan and Mesothermic weren't just two weird anomalies. They were part of a larger trend toward warm bloodiness among dinosaurs, and that's good news for solving the mesothermic mystery. That's because, like Ms. Chan, most dinosaurs are represented by only a handful of fossils, which makes it hard to draw conclusions about their body temperatures. But if we can find more evidence of endothermy or the ability to generate heat internally, then we can start piecing together the warmth of the entire theropod group. And learning more about what dinosaurs were like will help us understand how they evolved and why they went extinct. It'll also teach us more about the world they lived in, and how life on Earth has changed over the past 66 million years. Plus, it'll just make us better storytellers. After all, who wants to hear about a scaly, flightless lizard when you could hear about a charismatic, feathered dinosaur that poops its pants? Okay, but maybe that's just me. Thanks again to Brilliant for supporting this episode, and thank you for watching.